Okay, today is April 19th, 2022, and we have 4 surface area questions of the 4 right prisms that we have been studying in class. Now remember, a right prism, just so we remember, has a base and it has a height. And the base, in this particular one right here, if I take my highlighter and highlight it yellow, the base is this shape right here, which is a rectangle. And the rectangle at the top is going to be the exact same dimensions as the rectangle at the bottom. That's because the sides, and I'll highlight those green, the sides of this particular one go up perpendicularly to the base, which means they go up at right angles. So we call these right prisms because they are at right angles with the base. So the first one we have here is a rectangular prism. And if I was to break apart this rectangular prism into what we call a net, it would have a front, a bottom, a back, and a top, right? And it would have this length here, so match this one if I fold it up. So something like that and like this. That would be our box if it was broken down into a flat rendering of the three-dimensional object. And we call this a net, right? It's a flat rendering of a 3D object. Now if I think about the largest size, this one right here, this is the bottom of it, and it would be 10 wide and 10 long and 6 wide, meaning it would have an area of 60 units, right? Because it's a rectangle, it's length times width, so it's 10 times 6, which is 60. And the top of this rectangular prism would be identical to that. So the top, if I put bottom here, this one would be the top, and it would also have an area of 60. Now the front, which I'll highlight yellow here, its dimensions would be 10 wide, and this one here, which is 2, the height of the actual box itself would be 2. So that front, if I put an F here for front and B for back, the front would have an area of 10 times 2, which is 20, and the back would also have the same rectangle, and we'd have 20 for that. And finally, our left and our right, if I grab a green highlighter, and there's our left side, we'll just make it green there. That is going to be a length and width of 6 and 2, which means it has an area of 12, and same with our right. So when we draw our net for a rectangular prism, we have this net drawn with the areas of each face, all 6 faces in there. If I was to add it together, I'd go 60 plus 20 plus 20 is 100, 160, 170, 180, 184. So the surface area would be 184 units squared, making up the area or the combined area of all 6 faces, otherwise known as surface area. Now there is an easier way to do it rather than drawing a net. You can use a formula. So we have 2 rectangles that make up the front and back, and we have 2 rectangles that make up the left and right, and we have 2 rectangles that make up the top and bottom. So since a rectangle's formula is length times width, we have 2 LWs plus 2 more LWs plus 2 more LWs, because that makes 6 rectangles in total. And I'm going to put a TB here to represent the top and bottom, which is a matching pair, the FB, which is the front and back, and the LR, which is your left and right. So if we think about the top and the bottom, our top and our bottom were right up here, and that was a 10 by 6. So we have 2 rectangles that are 10 by 6, and we have 2 rectangles, the front and back were 10 by 2. And we have 2 left and right, which were 6 by 2. So we have 2 of them, which are 6 by 2. So now we've substituted our information in. We have a bed mass question with multiplication and addition. We'll do our multiplication first. 2 times 10 is 20, times 6 is 120. Plus 2 times 10 is 20, times 2 is 40. 2 times 6 is 12, 12 times 2 is 24. And when I add those together, I'm going to get 184 altogether, or 184 square units making up the surface of that particular rectangular prism. So that's how you would do it 2 ways. You need to be able to do it first with a net, and then you need to be able to do it with a formula and some reasonable bed mass skills. Our next question is a cube, and that's the really easiest net to draw, because if I think about a cube, I'm just going to infinite clone this, watch this. So you have 4 squares. I should bring this up a little bit, whatever. 5 squares, 6 squares, which make up all of the faces of that particular prism. If I broke down that box, it would be like that. And if I think about this, in fact, I should draw my dotted lines here. Our all of our sides are going to be 20 by 20. And since 20 by 20 is 400, each of these faces has an area, an independent face area of 400. And since we're looking for the combined surface area of all of the faces of the surface of the cube added together, it would be 400 times 6, which is the surface area would be 2,400 units squared. Okay, that's using a net to find your answer. Now, if we think about the formula, since side squared is the surface of one square, is the area of one square, and there are 6 identical ones, we're going to put a coefficient of 6 there and say the area, surface area of a cube will be side squared multiplied by 6, or 1 squared multiplied by 6, or 6 independent square faces. If I substitute my side length in my square is 20. So I have 620 squareds. According to BEDMAS, we do brackets first. There's nothing in that bracket to simplify, so that's not a B. Then we have E, which is exponents. So we're going to do our exponents next. 20 squared is not 20 times 20, or not 20 times 2, but 20 times 20, which is 400. So we have 6 that are 400 each, which is 400, or 2,400, excuse me, square units of surface area, right? So just to reiterate, formula, substitute, simplify, and get your answer. That's how you do it with a formula. Our next question gives us a triangular prism. And the first thing I always ask in the true-false question is, a triangular prism has 6 faces. The answer is false. It has 5 faces. And it's really hard to see from a 2D rendering all 5 faces. But if we break it down into a net, we can kind of see it a little bit better here. So we would see that if I folded all those up like an origami project, I would end up with 5 faces. Now, the triangle face has been magnified over here to help you kind of figure out the area of that. The base is 10, the height is 4, so base times height divided by 2 is your formula, or 10 times 4 divided by 2, or 40 divided by 2, which is 20. So when I write triangular prism, the triangle at the bottom is the same as the triangle on the top, and therefore both have areas of 20. Now it gets a little bit complicated. So if you notice here, I have a line here and a line here, which means those 2 lines are the same. So in those 2 triangles, which are 6 each, this rectangle on that side, and I'll try and highlight it yellow, this one over here, or blue, I guess. That rectangle at the back, and I'll do a yellow one, and this other one at the side here, these are both in the back 2 corners. Those are both going to have dimensions of 6 by whatever this is, and I didn't even list it, did I? I think it's 10, was it? Oh, I didn't even list the height. Oopsie daisy. Let's make it 20. I think it's 20. It's 20. My bad. We'll put 20 there. So 6 times 20 means that this face right here, if this was 6 and 20, this would also be 6 and 20, which means both of them will have areas of 120, 6 times 20. And then finally the front side, which we'll highlight green here, is going to be this dimension here, which is 10, 10 by 20, which means this area is 200. Once we have that written down, we're going to say 200, 300, 400, 420, 440, 460, 480. Our surface area is 480 units squared. Right, 480 square units, whatever it happens to be. Now, if we use our formula, from a basic standpoint, it's 2 triangles plus 3 rectangles. But we're just going to go, since we have 2 of them that are identical. This one here and this one here were identical rectangles. We're going to say we have 2 identical rectangles, and we have 1 non-identical rectangle, 1 different rectangle. So, oh, sorry, I shouldn't have had LW there. I should have rectangle. Oopsie daisy. We have 2 rectangles and another rectangle. Now that we have that, we can substitute our formulas. So since a triangle formula is this, we're going to put a coefficient of 2 and say we have 2 multiplied by base times height divided by 2. Plus we have 2 similar rectangles, and we have 1 rectangle that isn't like the others. And that formula right there should be able to be used to calculate the surface area of this. So we have 2 base times height divided by 2, or 2 10 by 4 divided by 2s. And since the rectangles that are the same, we have two of them that are both 6 by 20. Right? Not just one of them, but two of them. Right? Two 6 by 20s. Oh, two 6 by 20s. And we have one rectangle which is unique. It is a 20 by 10. And those would represent all 5 faces. So notice in algebra, when you multiply by 2 and divide by 2, you can put a line through it. And if you did that, you would end up with just 40. Now, if you didn't, you would have went 40 divided by 2 is 20, and 20 times 2 is 40. Either way, when you simplify that, you're going to get 40. Right? As we can see here, those are actually what the 40 comes from. And then you have two 6 by 20s, which 2 times 6 is 12, times 20 is 240. And then you have a 20 by 10, which is 200. And when you add those all up, you're still going to get 480 units squared as your surface area. So again here, a formula without numbers, a formula with variables. Substitute them all in, and then simplify them using BEDMAS to get your final answer. And the last one is the new one we did today, which is your cylinder. And remember, there are 3 faces. Oh, that's not what I wanted. There are 3 faces. The 3 faces are 2 circles. And if you cut open a cylinder, you would realize that it's and a rectangle, right? And we said that when you draw that as a net, you have your rectangle, you have your top circle and your bottom circle. And you can kind of imagine if you put the circle down and rolled that rectangle around it, you would have a perfect cylinder construction. So our net is those 3 faces. Our formula for this circle, actually both circles because they're identical, is pi r squared. So 3.14 multiplied by, now this number here is the diameter. So if the diameter is 12, the radius is half of that. Do your exponents first. So 3.14 multiplied by 36. And 3.14 multiplied by 36. 3.14 multiplied by 36 is 113.04 as the area of one circle. And since it's a right prism, the bottom circle shall be the exact same measure, and it's also 113.4 square units. 0.04. Now it gets a little complicated. And what you need to think about, and I'll grab a highlighter here because it's easier with a highlighter, is that this distance around here is called the circumference. And if I use a yellow highlighter to highlight that, that measurement should be the exact same length as that. Now, if you're having trouble seeing it, take a piece of paper, roll it up, and envision that top circle. But if you fold it back together in your head, you would see that the circumference of the top circle matches that length. Okay? And you would also think that the height of this prism will also be that measure of the rectangle. Okay? So essentially, this yellow line is really the circumference, right? The circumference of the circle, E-N-C-E, I can't spell. And this one is actually the height of the actual cylinder itself. So instead of using length times width, we could use circumference times height, right? We could say circumference multiplied by the height. But how do you get circumference? Well, back in grade 7, you learned that circumference is equal to pi multiplied by diameter. So instead of saying circumference times height, you could say pi times diameter times height, or very much simpler, just say pi dh. And that will be your formula we use to get the rectangle's length and width. Instead of saying length and width, that's really circumference times height. Circumference is really pi times diameter, so therefore pi times diameter times height would be our own variation of simply the length times width. 3.14 multiplied by the diameter, which is 12, multiplied by the height, which is 20. 3.14 times 12, grab my calculator, 3.14 times 12 times 20 is 753.6. That's the area of that rectangle. Add those together, 753.6 plus 113.04 plus 113.04. The total surface area of this particular one is 979.68 units squared. That's your total surface area for the cylinder. Instead of using your net, if you think about, well, it's two circles and one rectangle, it would be 2 pi r squared plus, for that rectangle, we already agreed that we're not using length times width. Instead, we're going to use this pi dh. So I'll write that down like this. Substitute our information, so we have 2 pi r squared plus pi dh. We now have additions, exponents, and multiplications. We're going to do our exponents first. We have 2 pi r squared is 36 plus 3.14 times 12 times 20. Extend this page a little bit. Take our calculator out. So 2, I better bring it up here, times pi times 36 is 226.08, that multiplication, plus I got to do my other multiplications. So grab this and go pi times 12 times 20 is 753.6. Add those together, and you should have, what do we have before? 979.68. 979.68 units squared.